Alright, so today, this is day 106. Today we're going to be representing and describing transformations. Transformations are, we could take an original object, okay, and we can do some certain things to it, okay. So before we start, let's have people in the video pause it and write the title and the objective down. Okay, so there are different kinds of transformations. Okay, so I'm going to make an x and y axis up here. That doesn't look very good. Here's a better one. Okay, and let's just say I had a circle here. Let me move it someplace that's going to be very easy to see. Okay, I got my circle right here. Well, actually, a circle is kind of hard to deal with. Let me pick a different example. Let's say I have a rectangle or a triangle. Okay, triangle is actually the best. Okay, I got my original triangle. Can you all see that up there? It's kind of dim, I know. Okay, this is the original. Okay, so just look at that. Now, what happens if I were to put a mirror right against the y-axis? Let's just pretend the y-axis was a mirror here. Okay, I put a mirror. Wouldn't it look like I flip it? Right? Wouldn't it look like I would have a line here, here, and here? Actually, this doesn't look right. Does that make sense? When I flip the image to the new one, this is called a reflection. Let's all say reflection. Okay, good. So that's one way to do it. Another thing you could do is we can take the original image and I can slide it, okay? So I'm going to take my original image and I'm just going to slide it down. Let's just say I slide it down all the way down here. Okay? Notice how I took the original image and I just slid it down? This is called a translation, okay? Okay, let's all repeat. Translation. Translation. What was the first one called? Reflection, okay? Reflection and translation, okay? There's a third one, okay? The third one is when we take the original image and we turn it. Let's just say we turned it and made it look like this. Okay? I just took this image and I turned it. What's this called? Rotation. Let's all repeat. Okay, good. So what was the first one called again? Reflection. What was the second one called? Good. Third one? Okay, the last one. The last one is when I take my original image, okay, and I make it just bigger. It's the exact same image except that it's just going to look bigger. I zoomed in on my iPad, okay? That's called a dilation, when I zoom in or zoom out. This is called a dilation, right? You know, like you have your eyeball, everyone? Look at your eyeball. Look at your eyeball. I'm just playing. Okay, so you have eyeballs, right? And you have a pupil in your eyeball. Your pupil opens and closes. They call it dilation. It dilates, right? Does that make sense? Depending on how much light your eye is wanting to take in at the time. So when it's really dark, your pupil opens very big. It dilates really wide. And when it's really bright out, your eye is trying to protect itself from all the light, so it's dilating and becoming smaller. Does that make sense? So that's called dilation when we change the size, right? Or when you're on your cell phone and you zoom in, right? Or zoom out on a picture, it's a dilation, okay? So let's all say dilation. Okay, so what was the first one? Good. What was the second one? Good. What was the third one? And what was the last one? Okay, good. Okay, those are the four, okay? The last thing I wanted to talk to you about is an image being we're going to have the original image. We're going to call that the pre-image. It's the OG image? No. Because it's the original, okay? The original image is called the pre-image, okay? And the post or the image that it becomes is just an image, okay? If the image that it becomes is the same, it's called a rigid formation. So you see how this is the same exact shape as the original, the reflection was? It's rigid. When I change the size of it in any direction, it's non-rigid. You see how this is non-rigid? This is not the same shape. Okay? So those are the terms we're going to go by. Okay? So you don't have to write this down. I already talked to you about a lot of this. Transformation is a function that changes the position, shape, or size of figure. Okay, what were the 4 transformations again? What was the first one? Reflection. I'm going to repeat. That's all purpose today. We're going to repeat ourselves over and over and over and over again. Okay, so again, what was the first one? Reflection. Second one? Translation. Third one? Rotation. Last one? Dilation. Good, okay. The pre-image is the input. It's the original or OG image, okay? The image is the output of the image. So when I say I want to reflect something, I'm going to have the original one, I'm going to reflect it. And math is going to help us to reflect things. Then we got prime notation is what the ordered pair or the point will look like after. Jonathan, please focus this way. Thank you. Coordinate notation is when we have the 2 points. And then a rigid motion is a transformation that changes the position of a figure without changing the size or shape. Okay? So here's some properties from the video or right now. You can read through these. So these are some of the rules. But basically the big idea is we are keeping the original shape. Okay? Here we go. Numbers 1 and 2. Ready? We'll just do number 1. I want to show you how easy it is, and then we'll do the next few together. Okay? So number 1, we got find the unknown coordinates for the given rule. Okay? I got a pre-image here, which is what kind of image? What did I say a pre-image was? The original. I didn't say original. I said it was the what? Oh, yeah, it was OG. It's the original. Thanks. I'm trying to make it fun, but I guess I'm not cool enough. All right, so it's the original, right? So check this out. Eyes up here. So I'm just going to draw my picture down here. I'm taking my original pre-image ordered pairs, and I'm going to go put them down. You got 0, 4. I'm sorry, 0, 4 is up here. So this is our A. And then we got 3, 0. This is our B. And then we got 0, 0. This is our C. And then I'm just going to draw an image connecting these points. And hey, look at that. What kind of image is this? It's a triangle. Okay. Right? I think you said rectangle. No, not a rectangle. It's oh, right triangle. Sorry. Okay. I want to make sure. Okay? So that's the original. I'm going to use a different color now. I'll use green to show you the difference. A prime is your new point that we're going to create based upon whatever the rule is. Our rule here is saying we're going to take our original image and then we're going to take the x value, we're going to subtract 4, and then we're going to take the y value and subtract 3. Okay? So A prime. So the original one was 0 for x. But over here it's saying take x and we're going to subtract 4. So we're going to say 0 is our x and we're going to subtract 4. Okay? The y value is 4. Okay, eyes up here, eyes up here. The y value is 4, and we're gonna. It says take your y value, subtract 3. So we're gonna go 4 minus 3, which means check this out. We got 0. What's 0 minus 4? Negative 4. What's 4 minus 3? 1. Okay, so this is our A prime. Okay, this is our A prime. A prime. Okay, bless you. So we're going to go to negative 4, 1 and put down our point. So I'm going to go down to here. Negative 1, 2, 3, 4, and up 1. That's your new A prime. Okay? Okay, now we're going to do that again. We got our point B. We want to take our x, which is 3, and we're going to subtract 4. So we're going to write down 3 minus 4. And then our y is 0. We're going to subtract 3. 0 minus 3. Okay, and then we're going to ask ourselves, what's 3 minus 4, everyone? Negative 1. Good. What's 0 minus 3? Negative 3. And then this is our b prime, okay? So we're going to go to negative 1, negative 3. -1, -3, plot a point. This is our B prime. Okay, last one, C prime. We're going to take 0 from our x, and the rule says subtract 4, so we're going to write 0 and subtract 4. And then our y, we're going to subtract 3. That's what our rule says. Okay, 0 minus 4 is -4. 0 minus 3 is -3. And this is our C prime. Okay, -4, -3. We're going to plot our point and draw our figure, which is C prime here. Okay, so what do you notice about my figure? Okay, so does it look like it's the same shape? Did it reflect anywhere? Does it look like it reflected? No. Does it look like it translated, like it slid? Yeah, it looks like it slid in 2 directions, right? Looks like it slid to the left and then down, right? And we could see that by our rule, it slid to the left 4, and then it slid down 3. You see that? Cool, so this is called a, what again? It's called a translation, okay? So we're identifying what kind of transformation it was. This is a translation. And then I want to figure out also, is it rigid? Remember, rigid is, did it keep its original shape? Did this keep its original shape perfectly? Yeah, this is rigid transformation. And that's it. That's all we're doing. Okay, I don't want to spend too much time doing all of them for you because I want us to do these together. So that's how we do number 1. All right. So what I'd like you to do, if you're on the video, please write this down. Please pause the video here. Okay, good. I like that. I like hearing. Oh, I get it. Okay, cool. Number 2. Number 2. Here's our original. This is the pre-image. Okay, these are the ordered pairs, and they already plotted them for us. I'll make them red so you can see them. There's J here, K, and L, and then there is a line here. So I'll make this my original. Okay, my rule is this. It's saying that I'm going to take my X and my Y, okay, and I'm going to, look what it says it's going to do with X. It's going to multiply your X by 2, you see, and then you're going to keep the Y the same, okay? So are we changing the Y's on my image? No. So let's make a little table here. Let's do 3 of these, okay? And let's just start with the Y's because those are the easier ones, right? If we're not going to change the Y's, let's just keep them the same. You see how J has a 2 for Y? Let's put a 2 here. You see how K has a 2 here? Let's put a 2 here. Hey, students, I need you to focus. Thanks. You good? Okay. It's all right. Focus. I need you to work as I go. Okay? You're making a table like mine. Thank you. Okay, so then we got our J. Okay, look at J now. Our X is -1. Okay? What are we supposed to be doing with our X values? What is the rule telling us to do? We're going to multiply it by 2, right? So we're going to take -1 and multiply it by 2, okay? And then we're also going to do that with K. We're going to take 2 and multiply it with 2. And then we're going to do KL. We're going to take our value of 2 and multiply it by 2. Okay, now we're going to work this out. What's -1 times 2? -2, and then we're going to keep the Y the same as 2. So that's my first one. So I'm going to go to -2, 2 on my graph, and plot a point. And this is my J prime. Okay, J prime. Okay. Then we got K is 2 times 2 is 4. So, and then we're going to keep 2. And then my L is 2 times 2 is 4, and we're going to keep -4. Okay, so we got J prime, K prime, and L prime. Okay? So we got -2, 2. That is J. K is 4, 2. And then we got 4, -4 for our L prime. Okay, look at what happens when I draw my lines between to create my image. What do you notice about the image? What do y'all notice? Turn your group. Is it translated, rotated, reflected, or dilated? What do y'all think? Is it reflecting at all? No. Is it sliding, like translating at all? No. Is it rotating at all? I don't think it's rotating at all. Nope. Is it dilating? Yeah, dilating just like your eye pupil. It's stretching, right? Do you see how this image is stretching? It's becoming bigger, right? Which way is it becoming bigger? The X's, the Y's, or both X and Y? You caught yourselves. X's, right? Does it look like it's getting taller or shorter? No, it's only getting wider, right? So it is dilation. Good. Okay, so this is a dilation. Dilation, okay? And I got a question. Is it a rigid or non-rigid transformation? Non-rigid. How do you know, Emily? Good. It's not the exact same shape as the original pre-image. Does that make sense? Do you notice how the sides are different lengths? Right? Good. So it is non-rigid. Excellent. Okay. Let's keep going here. I know that I could do a lot of these for you, but I would like you to think through some of these. Okay, so now we got number 3. Number 3, okay? We got a pre-image and an image. They actually showed them up here, so I'll draw the pre-image and image so you can see them better. The pre-image, we got -3, -1 for our P, and then we got 3, -1 for our Q, and 1, -3 here. And this is our pre-image, okay? And our post-image, or actually the just image, looks like this, okay? What's the rule? What's going on here? Well, what transformation is happening? What would the rule be, okay? I'm going to give you about a minute to discuss with your neighbors. What's going on here that it would go from the red shape to the green shape, okay? Ready, set, go. What kind of transformation is it? Reflection, good. It is a reflection. So what's the rule? What are we doing with our X's and Y's? Well, let's look at our X's. Are our X's from the pre-image the same as the X's on the post-image? Yeah, they're exactly the same. So our rule should include that the X's are just going to stay the same, okay? What about the Y's? Let's focus on the Y's. I'll use a different color. Let's look at the pre-image Y's and the image Y's. What's going on there? What do you notice there? They became positive. Okay, so what are we doing to the original ones to make them positive? What would you do? Multiply, add, subtract, divide. What would you do? Good. They multiply with like -1, right? So it's like -1y. Does that make sense? Okay, good. All right. That's exactly right. It's a reflection. And here's our rule. Okay? Let's do the next one. With your group, what's going on this one? This one you're going to have to draw it out. So draw out the points and talk to your group about it. What's going on this one? Okay, go. Okay, it is hard for some students. So let me write this out. -1, 1. This is your F. And then we got 1, -1 is G. And then we got H is -2, -2. Okay? And we got original. That's our original red one, okay? Students, I need you to focus. Okay, so the next one is F prime is -2, 1. And then we got 2, -1 for G prime. And then we got -4, -2. Okay, so turn to your group, tell them what's going on here. Okay, and what's the rule? What's happening? Okay, go. This is a dilation, and I got a question for you. What's the rule? What's happening to them? Oh, dilation. Okay, so we're multiplying x by 2. Okay, so 2 times x and then what, comma what? Is my y, are my y's changing? No, but my x's are being doubled, right? Y'all see that? Okay, good. That's it. All right, and this is important, right? Because, like, let's say you're a computer programmer or you're programming code for a program. This is what they're thinking through. They're thinking like, okay, if someone is, or you want your video game to stretch out or to dilate, or you want an object to rotate, or you want it to translate across, or you want it to, what's the last one? Reflect, right? Then you need to know how to be able to program, and these are the basic concepts and logic that you're going to use, okay? So, yeah. Cool. That's it. That concludes the lesson.